With Carlson Survey, you can open up several different formats of data files, field data files. And in this video, I'm going to demonstrate how to open up a Trimble DC file and edit it in Carlson Survey. You want to start by creating a new drawing. And we're going to use a template I made today that actually includes a background aerial, very blurry, of the Missouri City area. I find the aerials are nice when you're trying to figure out where you are on a file, whether what area you were collecting data in. So there is our template. Now we're going to give this drawing a new name. And we will call it simply Field Data Processing. You could probably give it a better name. So you'll have several of these at the end of the project. So a unique name for each is a good idea. Once we have the project set up, we identify that we want our field data to be saved in our survey data folder, and that we're not going to open anything when we start the file. So that file is created. Now we want to open up in Carlson Survey under the Survey tab the Edit Process Raw Data file. It's under the Survey tab, and I believe it's also in the Survey pull-down menus. Edit Process Raw Data. When we get to this screen, we need to open up our particular field data file. And at this point, you should have already saved your field data file to the survey folder and given it a unique name so you can preserve your original data file in case you have to restart or redo this, which there's a good chance you may. So we're going to import and here's all the various formats. We're going to import a Trimble file, and you can see here that the extensions for the Trimble files that it can import are the DC or the JXL. And this on mine lists all of those files that I have in that particular data folder. So we're going to do the Trimble Missouri City DC file. So the first thing you want to do, it asks the question, store grid positions records as points or notes. Well, we need those stored as points. And then prism constant of 10 millimeters found in the raw data. Adjust distances by prism constants. I think that Trimble has probably already applied those constants to the dimensions in this file. So I'm not going to apply those now. If I find out different, I will apply them later, but for now we're not going to apply them. 10 millimeters is 2/5 or almost 1/2 of an inch of adjustment per setup or shot. So here's the file. There's various codes on the side. They mean different things. The DC, I believe, is just a note, and a PT is a point. So these are the control points that you have brought in the files. And then this is where it starts your field book type data. Your instrument is set up, or this is the coordinates for point 2, and you're set up with an instrument height, HI 4.718, and you're set up on point 2, and you're back sighting point 3, and you have a rod height at 6.5. There's a prism constant of 10. So now you're going to foresight point 3 again, So when you do this and you shoot it and you save this again as 0.3, you're going to have 2.3s. And one's going to be the control point and one's going to be the point you just created when you took this shot. So the best thing to do is when you're foresighting, when you're taking a side shot on a control point, give it a new number or just let it be the next number in the sequence. And then in the code, make a note that it's a check shot and then a check shot and then put the original number in there, check shot of 0.3. So here we go again. We're back on instrument. We have an instrument. We have the same setup with a rod height now of 5. So we changed the rod height. And then we're going to start shooting these various CP points, nails. And these are all control points. So these are all check shots. So I'm thinking these should be given unique numbers because you'll see later at the end that we have shots in here that it doesn't know what to do with. So right here, text that it's in this color are traverse points or check shots. The blue and the SS off the side are the side shots. These are the actual shots that you made to each point, and this is the descriptor code. Now you can change anything in this file, and then you save it, and then when you reprocess the coordinate file, it'll take that into account. For example, right here you had a rod height of 5, and then you started taking these side shots. Maybe after you finish, you realize that you weren't on pot 12, that you were actually on point 13. You can put 13 in there, and then it'll go back through later, and it'll recalculate the whole file like you were set up on point 13 with the coordinates that you already had stored. Say, for example, at the end of the day, you realized, or at some point you realized that you didn't change your rod height. You had been going through thinking you had a rod height of 5, but then all of a sudden you remembered back in here when you took this edge pavement shot, edge concrete shot, you had to raise it to get over a car. Well, you don't have to go back and reshoot everything. You don't have to figure out what the difference in the elevation. You can simply come in here and add a new instrument height file, and then you leave the HI empty, and then you put a new rod height in of 5.5. And when it's finished, it'll recalculate all the points with the elevations based on an 8.5. You have to remember where you went back to 5. So say right here, you went back to 5. You would add another one with a rod height of 5. Then you can go and process. Maybe you realize that you have a bad code. If you change the codes in here, it changes the codes in the coordinate file that you download. So you don't have to change it again. But it's very clumsy to change codes in here because you have to do them one at a time, and there's no way to do more than one at once. So, but if you have one where you realize you really need to change it, you can. So once you've made all your changes, you want to save this file. And I'm going to give it a new name because I've modified it. So I'm going to take the original file and I'm going to add modified to it because I want to keep the original file in case I have to start over. So I'm going to put modified in front of that, and I'll put today's date on it. And it'll save it as a RW5. That's a Carlson file. That's automatic. And save it. After you save it, this is still just your raw data file. You need to convert this into coordinates. The way you convert it into coordinates is you go to process points, and you first time through you may need to check your process settings, distance tolerance, multiple shots. I don't think we're going to have multiple measurements to the same point, but we could probably live with a 0.5 difference, 0.05. We want to report the residuals in coordinates. We want to override the backside azimuth when we have a backside coordinate file. So if you have a point coordinate file, you don't need an azimuth, you're just going to backside that coordinate. And then we're going to tolerate up to 500's difference in the distance between the instrument setup and the backside. Report blank descriptions, I suppose that's a good idea. We're not going to draw this by field to finish. We want to go in, we want to save it and then go into the CAD file and then draw the field to finish once we're inside. Store point records to CRD file, always. And then OK. Now that's the settings. Now to process the points, we don't need to do the compass or the rand or the transient or least squared. If you had GPS data, you would use GPS. But in our case, we just don't want an adjustment. We just want to create coordinates based exactly on how this file is written. There's really nothing in here you need to check. We're not going to do a scale factor. We're not correcting for earth curvature. So we're okay. Now, these are the PTs. These are the points I was talking about. These are where we shot the extra control points. So we ended up with 2 points. That's why they said there's PTs. But we can just ignore that for now and just continue processing. And here's your report file. So we had 1 traverse point. We shot in 2,170 points. And the distance, I guess, from point 1 to your next point was 60 feet. I'm not sure about that. Most of the errors here, this is in a tenth. This is 700s, this is 700s, this is 800s. So nothing significant here. So we're pretty good. So we're going to close that report, or you print if you want. And then we're going to file. I'm going to save this raw file again. And then it's already going to save the CRD file. It does that automatically. But I'm just going to go ahead and save the CRD file. That's the Carlson version of a coordinate file. And then I'm going to close this. This video is already 13 minutes long, so I'm going to end it here and start a new video and show you how to bring that data into your Carlson drawing.